Hello everyone, it gives me immense pleasure to welcome you all to today's Glass Academy webinar on Glass in Modern Architecture, Sustainable Facade Designs. I hope you're as excited as I am to dive into this fascinating topic that connects architecture, sustainability, and cutting-edge design solutions. In a world striving for sustainability, our built environment plays a critical role in shaping a better future. Facades are more than just the skin of a building, they're the key players in optimizing energy efficiency, occupant comfort, and overall environmental impact. And when it comes to facades, one material stands out for its versatility and transformative potential, that is glass. Glass is not just a design element, but a tool for sustainability, balancing daylight, thermal performance, and energy conservation. It's no wonder that architects worldwide gravitate towards glass for its unique ability to merge functionality with aesthetic appeal. Today, we'll uncover how glass contributes to sustainable facade designs and how it can help address some of the critical challenges in our industry. Now, allow me to introduce our esteemed speaker for today. We are fortunate to have with us architect 𝐿𝐴𝐚𝐧 𝐒𝐚𝐧, a distinguished expert in green building and sustainability. Architect 𝐿𝐴𝐚𝐧 is the division head, Sustainability and Green Buildings at 𝐊𝐴𝐴 Environmental, a division of 𝐊𝐴 Design and Projects Private Limited. She has been a part of the organization since its inception year 2009 and is based out of Pune. With her architectural background and a master's in environmental architecture, she has over 15 years of experience in the field. Architect 𝐿𝐴𝐚𝐧 is a green building accredited professional, a building energy efficiency expert, and a qualified BEE energy manager. She has delivered over 100 plus green building projects across India. She was also a part of ECBC and ENSL Maharashtra State and implementation of pilot EBEC projects under UNDP GEFBEE project of energy efficiency in commercial buildings. Her latest published works include a policy paper on Green Roof Policy Initiative for Future Cities and case study paper on mainstreaming low energy cooling systems in small to mid-sized commercial buildings. Recently, she was also a part of the technical carbon footprint analysis of infrastructure sector of Pune metropolitan region under the flagship program by Pune International Center for making PMR net carbon neutral by 2030. She has delivered the first platinum-rated IGBC Green Homes project in Maharashtra in 2012 and in 2022 delivered the first in Maharashtra and the third in India LEED BD plus CB for platinum certification project in capacity as a green building consultant. Currently, she's working on net zero projects, embodied carbon benchmarking, energy management in buildings, sustainability reporting, life cycle assessments, and integration of renewable energy systems. We're in a total treat as architect 𝐿𝐴𝐚𝐧 takes us through sustainable facade designs using case studies, tools, and strategies, highlighting why glass is the dominant material in achieving sustainability. Welcome, architect 𝐿𝐴𝐚𝐧, and without further ado, I will now pass it over to you to begin your presentation. You may now please share your screen and present, ma'am. Over to you.
Thank you, Anvita, for that lovely introduction. Thank you, Ethos and Glass Academy for having me here to share what I have learned and practiced till date, specific to the topic of glass and sustainability. So, yes, great. Hello everybody, and I'm here to share certain case studies on sustainable facade designs and the use of glass in modern architecture, and how glass and sustainability can sort of merge together, or how they have sort of started working together, and how we should probably look at changing our perspective towards glass as well. A very quick introduction about where I come from. So I head the Sustainabilities and Green Building Division at 𝐊𝐴𝐴 Environmental, whose core focus is helping businesses and projects to become sustainable step by step and embark upon a journey towards net zero. These are our specialisms where we work with sustainable built environment, energy and resource management, and also on the core ESG reporting and verification side, a few of our clientele, both listed and non-listed. We also do a lot of policy intervention works, which gives us an insight into how policies actually shape up the built environment. Core sustainability and life cycle assessment works, because glass as a material, how it really impacts. So what is its environmental impact? We're also looking at not just the operational side, but also the embodied side of glass as a material. With any sustainable project, it can be of any scale, right from cities, infrastructure projects to homes. Size doesn't matter. These are few of our key achievements, which I think Anvita also covered in her introduction. Why we are discussing sustainability today, a quick background. Here are the UN SDGs for you, the Sustainable Development Goals, 17 of them. And the world is sort of trying to make contributions towards these goals through any sort of business operations that they have. This is a quick insight because this is the future. This is where the world is heading to in each and every business operation that's happening around the globe. Predominantly, what this translates to our built environment is looking at the embodied and the operational carbon. So I'm going to give you a little bit of background even before entering into the core subject of glass, so that you take it along with you in your sort of growth in your profession and make the SDGs a part of your practice. India, like you said, that Honorable PM has set a target of carbon neutral India by 2070, and most companies have set their carbon neutrality goal up to 2040, if not 2030, which means a year-on-year carbon reduction has to be planned for each of these companies. So any new project you're designing, any new venture you are advising towards will have to look at decarbonization as a strategy. When we look at green buildings and green building certification, like you may have heard, they typically contribute to specific SDGs out of the 17 SDGs. So just for your quick reference here. Now coming to the subject of glass, basically I am not going to sort of present a very theoretical content in terms of if you go back to the building physics aspects of it. I'm assuming that climatology and the building physics aspects are already studied, and you know the definitions, so on and so forth. So I would love to share the learnings and have certain conversations through these case studies that I'm putting up. And how can we actually achieve decarbonization through energy efficiency as well as materials in facade design, with glass at its key. So when you look at glass, I mean, it's a beautiful material. It's very popular, and it's sort of, it can be used in various ways all across the globe. This is another very famous project, where the glass has been shaded using pixel-like, panels. These are a few of the projects, the green building projects that we are working on, designed by various architects. So you will see glass is extensively used. So whenever we have a dialogue about sustainability, green buildings and glass, I've often felt that use of glass is treated as a contradiction to the core idea of sustainability. So I feel it is very important to first address and acknowledge that yes, glass is the dominant material, glass is the dominant one. And I feel, first of all, we all as professionals in the industry need to accept it rather than reject it, resist it, or say that it shouldn't be used. Of course, it has to be very sensitively used. It has to be very consciously used, knowing the impact that glass will have on the energy consumption, on the operational side, on the embodied carbon side. Yes, but it definitely cannot anymore be standing against sustainability, is what I want to sort of strike a dialogue here. And it's about balance. What is beauty of the glass is its transparency, the way it allows daylight inside, the way it connects you to the outdoors. So there is a high level of aesthetics and connect that a person could have with a glass facade looking out of the window. Sort of that it's a very strong association that we can have, particularly from the indoors. We often look at facades from the external side, and we feel that yes, the outdoors should be really impressive and beautiful. At the same time, I feel we have a stronger relation from the interiors to the outdoors when we see glass. Now, so along with the aesthetics, it is very important as to how we balance the efficiency side of glass. How do we, along with the daylight, cater to the heat ingress that glass allows as compared to, say, a facade being completely opaque, for example. So it's sort of a balance that we need to achieve in our designs, and there are so many tools and techniques that we can actually use in our practice to achieve this balance. So, like I said, what's the most special quality of glass? Why do architects love glass? It is the transparency, right? It is the sort of the seamless flow of vision that you get when you look at a glass facade. Now, when you look at buildings in general, which are completely glazed, you will also see that you'd see a lot of blinds, right? So just like this photograph actually shows you that, there's a beautiful glass panel on the floor with the blinds down, right? So somewhere there is definitely a need to relook at how we are using glass, whether we are offering useful illuminance, as I would call it, or useful daylight, which is glare free, which does not hurt the eye, does not hit our skin directly, with a high radiation, uh, is actually the balancing act in the use of glass. A few key considerations which I would like all of you to note down actually are here on your screen right now. It starts with design and orientation of your building, which is the key. So use of sun path in order to, and also what weather zone, what climate zone you are in, to actually decide the orientation of your facades and orientation of your buildings and the zoning within that building would often directly impact on how you would use glass in a project. So, for example, you're facing, the west side, all along, the longer facade. Of course, you would have to, reduce your glass usage and control your window to wall area ratio, because the west is, will be exposed to the sun for the entire year with really low sun angles that are difficult to shield. But if you do the same thing looking towards the north, it would allow you a good amount throughout the year with a very optimized sunshade that you would need for the summer times. So orientation, your first step in design, is directly connected to how you're going to be able to use glass and how energy efficient your facades are going to be. Further to the orientation, then we start carefully looking at a terminology called window to wall area ratio, that is the WWR, as we call it, or as you could look into your building energy efficiency building codes or green building rating systems, the guidebooks. You would come across this terminology where it is highly recommended for commercial projects, particularly to reduce and control your WWR to less than 40%. So that is, out of the gross wall area that you have, the transparent area needs to be limited to 40%. Typically, you will see in commercial applications that this percentage, is somewhere between 50 to 60 or even more at times, which then means that there is an excessive sort of heat ingress that is happening into the project. And if this is not mitigated then with other measures like shading devices or an extremely high performance glass, it can really cause very high sort of input into the cooling loads of the project. So having control on the window to wall area ratio is the second then step where you are conscious about which orientation has what window to wall area ratio. So it may not be the same on all sides. It can vary. And it can vary based on the sun path, based on the radiation analysis. You have so many tools today to analyze. A tool as simple as SketchUp can also give you, shades and shadows, and the plugins can give you the radiation, or even the tables in the NBC can very easily allow you to make that decision very quickly. Then you have the balance between the solar factor and the daylight. So when we talk about use of glass, and if you read any brochure for any of the glasses, you will see a few factors, a few thermal parameters and visible parameters that the glass gives you. And often the heat and light will be in contrast to each other, in the sense more light coming in will also bring in more heat coming in. Whereas for our climates, for most of the Indian climates, you want to keep the heat away. So your solar heat gain coefficient, or the solar factor, which is the proportion of the heat that comes in, will have to be lesser. So there has to be always a balance between the daylight and the solar factor, the visible light transmittance, and the SHGC of the glass. So striking this balance, through your design as well as through the selection of the glass, again becomes very critical. And these two factors are to be, of course, assessed along with the internal external reflections, because ultimately, if the architect has a vision for a very transparent sort of a building and not a very reflective building, and if you choose a glass for the sake of these parameters, and if it turns out to be extremely reflective as compared to what the architect wants, it could completely, derail the vision and the aesthetics of the facade. So, of course, the solar heat gain coefficient and visible light transmittance and the thermal transmittance, that is the U value of the glass, are important factors, but they cannot be singularly, looked at. They need to be looked at along with the aesthetic aspects, which are governed by the internal and the external reflections of the glass. Then you also need to look at acoustics. With most of the urban projects, the noise levels, the outdoor noise levels are very high. So whether you want, what sort of a DGU or a doubly glazed unit you want to use, or whether it needs to be laminated for better acoustics, or the thickness needs to be varied. So that assessment also becomes very essential. And the last point, but definitely not the least point, is the fireproofing and the fire protection of glass, which again is, I think, a subject of expertise in itself. However, these 5 considerations, according to me, are the sort of base considerations and base aspects of selecting any glass. Moving further in design, what again the design needs to achieve is avoidance of glare. So, I mean, in the Indian climates, even if you punch a hole, create a window, you're going to get a lot of daylight. So it is not the availability of daylights that is an issue. It is the uniformity, how we distribute it, how we make it glare-free. So measures like light shelves, having very strategic shading devices, screens, will help us in avoidance of that glare. A less talked about aspect is weather sealing. So if we are envisaging the project to be sealed properly for air leakages as well as water leakages, this is a major issue that a lot of Indian facades face, and it is less talked about in our sort of practices, but a very important aspect, and it really can be a game changer. Then dimensional planning. By dimensional planning, I mean what is the availability of the sizes of glass, the sizes of the facade components, so that we can avoid wastage. Because any little bit of material also that we save directly reflects onto the carbon footprint of the the material. Because one needs to acknowledge that both glass and aluminum, which are usually used together, are high embodied carbon materials. So any savings that we bring about just by planning our grid right, just by planning the overall design right, will definitely help us reduce, the wastage in glass. So that is what I mean by dimensional planning. Once you have created a facade, also checking the facade post installation. So this is again, a trend that is yet to catch up on Indian projects, is building envelope commissioning. So once the facade is completed, once the glass is fixed in the aluminum, whether it is sealed properly, whether there are leakages, whether everything that is expected on the design board is delivered on site. So checking the building envelope post installations and during installations is something that also needs to be looked at, especially because of the kind of facades that we are making these days in large quantities. Also, end of life aspect. Again, a very new sort of a concept as to how will you bring down this entire facade at the end of its life. What would you do with this glass? So currently, after the sales of glass, currently companies are not necessarily taking this glass back. It is going into, maybe certain into the bottling industry, for example, or some other allied industries for the reuse of glass. But probably there is a scope for the industry to really improve on what they actually do with the end of life of glass, end of life of aluminum. In times to come, of course, with more and more talk on circularity, we hope that better channels for refurbishment of these materials will also be available. And of course, in the end, measuring the carbon emission of your entire facade design and how it looks, and whether you've made an effort to actually decarbonize that facade and in what ways. I've already sort of introduced, that climate plays a very important role in determining the thermal load. And when you look at the heat load calculations, you would realize that glass has the maximum impact on those calculations. So when you look at the building envelope, you have the wall, the roof, the windows, or the glazing, floors, and skylights. When we look at our codes, our green building systems, like I said, they would ask you to control the use of glass, primarily because it is a substantial addition into the onto the cooling loads and the heat ingress that happens into the building. So these are a few technical aspects that, primarily glass, when you look at it, it has a radiative heat gain as well as a conductive heat gain, which, correlates with the SHGC factor as well as the U value factor. So whenever we use glass, we have to ensure that these two factors are on the lower side, as low as possible. You can use the references in ECBC, in LEED, IGBC, GRIHA, in order to help you decide what factors you need based on your design, based on your overall design, and try and reduce that heat gain so that your air conditioning tonnage is reduced, or if you're naturally ventilated, then you have better thermal comfort indoors. So about, like I said, substantial amount of heat gain, around 60 to 70% in the daytime, is through radiation. Hence, that solar heat gain coefficient factor becomes very important when we look at glass. Again, a very quick break from glass, and you may, again, a sort of a reminder as to why we need to talk about reducing carbon emissions again. So when you look at the per capita emissions of India, you'll see that they're very low as compared to the developed world. They're close to about 2 right now tons per capita per annum. But when we add up all our emissions, we suddenly rank third or fourth in the world. It keeps changing, but third, India ranks third in terms of its total carbon emissions. So that is where we sort of need to relook at all these aspects while we are, following the developed world, in its approach of, say, facades particularly. A quick sort of question, that which one out of these buildings you think is a green building? Is it the hut, the humble hut that you see, or the very high-tech project that you see with a lot of vertical axis wind turbines, or a building with actual greens and biophilia on its facades, or the building with the screens? So basically, any project that we do, this is one of the quotes by Geoffrey Warner saying that the greenest square foot is the one that you don't build. So, but that's not the world that we live in, and so we need to sort of reduce our impacts through way of design. With design being one of the most powerful keys in actually addressing the impacts of environmental impacts of building construction. These are the codes that I was referring to in my talk before, the ECBC code. This is the published code, ECBC 2017, and the 𝐒𝐚𝐬𝐴 Samhita code. The ECBC 2017 is for commercial projects, whereas the ENS code is for residential development. These codes are now soon to be superseded with a new code called ECSBC, which is in its draft sort of stage. The draft has been published and it will soon be finalized. But any references to fenestration, to glass, to the values of glass, very specific to the climate zones, can be very easily accessed by everybody, all students and professionals, using these codes, along with, of course, the National Building Code of India. And these codes typically will balance between the heat and light, the balance that I was talking about. So ENS will definitely look at promoting a lot of natural ventilation, giving a lot of daylight, along with the use of and control of glass. So these are a few provisions for the code. The terminology called RETV, which again all of us in the sort of sustainable design domain need to sort of start using a lot. It basically looks at the cumulative impact of the entire walling assembly of the vertical members or vertical components of a building. And it also sort of gives you a guideline as to how much should be the maximum watts per square meter that it should allow through the walls predominantly of the project. Like I said, again, these are the green building certifications, various green building certifications that will also give you very specific guidelines for glass. So why do we design structures? Why do we design facades? It's primarily for comfort, thermal, visual, and acoustics. So our goal definitely has to lead towards these sort of our spaces to deliver thermal comfort, our spaces to deliver visual comfort and acoustic comfort. So I mean, these are a few again direct links that we have of glass and energy efficiency. So like I said, starting with orientation, so climate responsive architecture and reducing the lighting and the cooling demand becomes a key to the use of any sort of building envelope material. High performance building envelope materials, which include a lot of insulation materials along with glass. So glass also, when you see, you can have single glass, you can have double glass, triple glass. Most commonly used glass for commercial projects today in India is the double glazed unit, the DGU. But the DGU also has a very wide range of parameters. Like even if you look at the Saint-Gobain offerings, you will see that there's a huge range of solar control and daylight control and reflections, internal and external, that various sort of options of glasses offer you. So you need to decide which one. And once you've done that, once you've done passive design along with the correct selection of the building envelope materials, then for energy efficiency, the rest of the measures can actually trickle. Another interesting conversation I want to bring to all of you to think about it and to sort of practice it is mixed mode ventilation and operability in facades. So you would see today around you, the buildings around you are are handicapped in the sense that you cannot very easily open their facades. There are safety concerns, there is dust, there is noise, there are so many concerns around us, which are not addressed in design. And then the most easy thing to do probably is to just, shut down the facade and have the operability just enough to meet the fire norms, the fire safety and fire protection norms, so that the smoke can go away from the facade in case of an emergency, in case of a fire. But here I want to urge everybody to actually think about mixed mode ventilation and having more operability in facades, higher percentages of operability in facades, particularly for mid-sized commercial projects. So today we see not just very large commercial floor plates or very large office floor plates, but also very small floor plates are going ahead and completely shutting their facades and then being forced to use air conditioning. Because once you shut the facades, you have no way to ventilate the space very easily, and for even climates in India which are not which are okay to operate on adaptive comfort mode with mixed mode sort of ventilation and using your ceiling fans and low energy cooling strategies, are then disabled from using them because there is no natural ventilation available into the space because you have sort of a sealed facade. So this is a dialogue which is very important, I feel, today, and it can very quickly decarbonize our operational consumptions. So, around the use of, glass and operability with facades, I'd like to present now further a couple of case studies which we will go ahead with. Deliberately, so these are not very large case studies. So they are mid-size, case studies which have deployed very interesting strategies on their facades. And in also the design of the facades also sort of corresponds with their cooling strategy, with their air conditioning strategy. And it also corresponds with the acceptance towards adaptive comfort within the spaces. So the first case study, which is office building for a company called Electronica Finance Limited, it is located in Pune, and the dialogue for this facade actually started with the acceptance that yes, we are okay with not having air conditioning for at least 6 or 8 months within the office. We are not looking for temperatures, operative temperatures of 21, 22, or even 24 degrees. Just to share with you, the adaptive comfort temperature for Pune is around 26, 27 degrees, which is very easily achievable through ventilation. I think here the architects definitely on the design board need a lot more conversation with the HVAC consultants or HVAC, the cooling experts on board right at the beginning of the project, so that the HVAC consultant can also give suggestions as to what could be the adaptive comfort temperatures, how can one achieve it, and sort of reduce the operational costs in cooling, which is one of the most highest consuming utility in any commercial or any building for that matter. So how we went about this, we went through an integrative sort of a process in design where we looked at the climate, we looked at the zoning, the massing of the project, which side do we shield. So the south was buffered as much as possible. It was kept opaque as much as possible. There were various simple box energy simulations that we did. So we used a design builder here, where we did quick sort of turnarounds in the decision making, that whether we use a single glass on this side, whether we use double glass, what do we do with the roof insulation. So we did something which is called as 𝐿𝐴𝐴𝐴𝐻, energy conservation measures. So we tested these measures using box simulations, and then sort of came down to certain conclusions. Because one must realize that it is not just that you can take the best of materials to be sustainable. It also has to be cost efficient to a project. So of course you cannot make a project which is extremely expensive and packed with all the energy efficiency features, and then having a very high payback. So that would also through the life cycle may not make sense. And I think being cost effective is as important as being energy efficient, as important as being sustainable, as important as being decarbonized. Is very much a part of it. So having sort of a financial analysis along with your decision making for what glass you use, what building and what level of insulation you want to give to the building envelope also becomes very critical. So like you can see, we have modeled it with and without the shading devices, because shading devices also cost you. Though you reduce the cost of glass, one must acknowledge that it's an additional element, an additional layer. However, for this particular project, what we did was we had a combination of sliding windows and facades. Wherein for safety purposes, the sliding windows allowed a lot of louvers, horizontal louvers in front of it, and whereas the facade was higher in its operability. So instead of having one single pane for a floor, which is so difficult to open, we had multiple panes on this facade, which anybody could easily have access to the facade and operate the facade. So yes, these were a few of our project goals where we looked at least 75% uniform distribution of daylighting, glare-free spaces to allow natural ventilation when we are not using air conditioning during the peak summers, to minimize the solar heat gain, to have thermally comfortable spaces and give exterior views and introduce a few vertical grids. That was a sort of a goal on the side for us. So again, a lot of analysis on the psychometric chart as well, looking at the windroses, doing some very basic, very quick thermal analysis, understanding what opportunities we had, and then we went for a series of options. So I'm quickly going to run through these options so that you have a gist of. So along with the facade design development and lures, the development of lures. So here our parent company, 𝐕𝐾 Architecture, did the facade design, and we did the environmental assessment for this particular facade. We were, along with the design development, also quickly assessing what kind of a daylight and what kind of solar shading is available for that option. So we went for multiple options. We went for screens, where again we looked at how the daylight looked. We went for certain options with very low window to wall area ratio. We looked at the context of the site. We looked at the greens on the facade. And side by side analyzed also the daylight as well as the radiation. We looked at the strategy for exhausting heat from the facade, because we had an operable facade. We needed an outlet, for the ventilation to be more effective. So we sort of worked along with the architects for that. And then further certain options were finalized, which then were combined to deliver the final option. But primarily here, the idea was allowing for a mixed mode ventilation and allowing for a more operable facade than we usually do, only to fit into the fire norms. So looking at shading percentages on each of the facades. So this was a simultaneous activity. So the design along with its performance. So performative facade designs, as you would maybe call it. And then there was an option that was finalized where this is the north side. So you'll see most of the, sort of blank glass that you see is towards the north, whereas the west and the east deploys more of louvers, with sliding windows behind it, so that it can be the floor plate can, beautifully get ventilated. And this really allowed us to reduce our air conditioning consumption of this project big time. I feel we are seeing currently savings of around 50 to 60% through the year. Strategically, the DGUs were selected with very high transparency, but with a very good U value of around 1.5 watts per square meter degree Kelvin, and a good solar factor as well of 0.25 to 0.3. So these are some quick snapshots of the analysis. This is how the building looks, where you can see that, these breaks that we have taken, the horizontal elements that you see that are usually more in number, on this facade, is to improve the operability of the facade. And the AeroBreeze louvers that you see have the sliding windows behind them, so that, there is no risk of fall. At the same time, you allow the winds into the building during the non-AC hours. And during the air conditioning hours, you can, shut them off. The hardware selection of the windows and the facade was done to ensure there are minimum leakages air leakages happening into the project. This also happens to be a LEED Gold certified project. This is the global version of LEED, version 4.1. Taking you quickly now to the next case study, which is also very interesting because here there is a very thick integration of the facade design and use of glass with the air conditioning system. This is a headquarter of Enpro Industries. It is an office building designed by architect Usha Rangarajan from Landmark Design Studio. The key words here, for this building were actually thermal comfort, air conditioning, indoor air quality, because often what happens in air conditioned projects is that there is not enough fresh air and your indoor air is affected. And often naturally we rely on facades for that fresh air to come, but in completely sealed buildings, that fresh air is also not available to projects. Disabled operability of facades was something that we wanted to definitely not do in this particular project, similar to the previous project, allowing for adaptive comfort, allowing for mixed mode ventilation. So if you see these 2 or 3 strategies for mid-sized projects can be really explored in mainstream. Then climate responsive architectural design, of course, that is the starting point of any project, any green project that we would do. And I would like you to mark the climate responsive HVAC design as well. So we often only talk about climate responsive architectural design, but in addition to the takeaway from here of mixed mode ventilation, I would also urge everybody to take away this terminology of climate responsive HVAC design, because the facades directly affect the air conditioning design and what can be permitted. I'd like to give you an example, which you will see in the further slides. This project cools itself using indirect direct evaporative cooling system, which requires a lot of ventilation from the facades. So if I do not design the facade in response to this low energy cooling system, then I'm going to be forced to do conventional air conditioning. So that is where I see that climate responsive HVAC design also sort of comes on board along with climate responsive architectural design. A similar pattern of analysis you will see here, studying again the micro climate of the project, setting your goals right. The solar passive design that was done beautifully by the architect, where the service areas blocked the entire west, the north was completely opened out. There was a central atrium which allowed us to exhaust everything that we were taking from the fascia. Like you can see, the window to wall area ratio, that is the use of glass for the overall building, has been restricted to less than 35%. So it's less than 40% for sure. And of course, the entire project uses DGUs, uses a doubly glazed unit, which is further also shaded on the south side additionally. So again, box simulations, again, to assess what level of insulation you need for the buildings, what are the materials you're looking at. Even in DGU, what are the different options for DGU based on their cost effectiveness that you're looking at. This is the south side that you see, wherein you see with and without shading devices, what is the kind of impact. So the cooling capacity actually reduces when you deploy shading devices. So it quickly allowed us to take a decision of, yes, let's go ahead and deploy the strategy on the south. Another very important probably discussion here is allowing every orientation to look different. So here both the architect as well as the clients were okay for each of these orientations to be responding to their climatic requirements. So if you see, the facades are not the same. None of the facades are same, because that is again sometimes a reservation that architects face, that you want it to look exactly same, which I think is another thing that you need to really get over, because if you want to really use glass at an extensive level, then it has to be treated in alignment with the sun path and the orientation. So in design, being open to this idea of having different looking facades also helps in achieving sustainability. So the pros and cons of various options. There were jalis. How do the jalis perform from outside when placed outside the glass? What impact they have on inside the glass? What should be the perforation of the jali? So all of these things, can lead you to the most optimized design. Then daylighting into the space, into the courtyard. So there's a lot of simultaneous analysis that was done while looking at even the skylights along with the facades. Then again, the selection of glass, like whether we do a combination of DGU plus the jali, or we do only the glass. or we do only the SGU plus Jali. So all this analysis and assessment sort of had to be there again to be cost effective and not because cost is always, like I said, a criteria, and it does affect the facade design. Also, something that we've observed in the market that often the facade installation comes last. So if there are overruns in the project, then facade is one of those elements where things can easily be compromised in their specifications. So again, I urge to all the project management consultants and to the teams that are actually making budgetary provisions, that please do allow for enough budgetary provisions into for the facade design, so that there are no compromises, because any compromise in the facade design hampers of course the thermal performance, the lifelong energy consumption of the project, and the safety aspects as well. So that is a point to be remembered and to be questioned right at the beginning of the project. A very quick glimpse of the terminologies I've been using till now as to the parameters that you need to see while selecting glass. Like I said, the solar heat gain coefficient being at the top of it. That is the radiative heat gain happening from the glass. Then the U value of the glass, which is the conductive heat gain. The VLT, that is the visible light transmittance percentage, that is the light that the glass allows to pass. So often you will see that the SHGC and VLT, like I said, are contradictory to each other. If you go for low SHGC, the VLT also drops drastically. In our experience, a VLT less than maybe around 27 or 30 sort of, really makes a major impact on the floor plate. So we can try and stay in the VLT bracket of 30 to 35 for Indian sort of climates, 30 or more, while giving the best of SHGC that is possible. So if you stay around an SHGC of 0.25 to 0.27, it should be, a good balance of both. And then internal and external reflections, depending on how the facade has been envisioned. If it is envisioned like a very jazzy and reflective facade, then the glass selection will change. If it is envisioned as a very seamless and transparent looking facade, then your internal external reflections number would change. And the glass manufacturers definitely will help you with a lot of tools and renderings to be able to for architects to be able to decide on the glass based on the combinations that you want. Like I said, because the facade was operable, the HVAC designer very quickly, I know this is a little off subject from glass, but it is because of the operable facade that we have been able to do a direct indirect, cooling, evaporative cooling, along with our air tunnel and a conventional air-cooled VRF for only the cabin spaces. So like you can see the exhaust, so the facades allow the air to flow in. The entire project is serviced with evaporative cooling, which is a lot of fresh air, treated fresh air being pumped, and then there is an exhaust that happens from the rooftop. So all of this whole system sort of works together to give thermal comfort and to be energy efficient at the same time without any compromise in the indoor air quality of the project. And in terms of the tonnage efficiency, I think conventionally we consider, consultants consider one TR, that is, tons of refrigeration for 250 square feet of space. We've been able to achieve a 625 square feet per ton kind of a design, which again, really saves a lot of energy. And this project is sort of also aiming to be carbon, net zero energy in the coming years. So with that goal, I think this design really this is the kind of design that one would have to do. A few glimpses of the earth air tunnel of the direct evaporative cooling systems that sit on the building. These are some views of the project. So if you can see how the daylight seamlessly sort of crosses through the building, and that the operable windows sort of allow the exhaust happening through the facades. The ceilings are open. And we've also mapped the actual energy consumption of this building, in the last 3 years, and we found that its, EPI is drastically lower than conventional building systems. and hence the project is now further considering towards the net zero goals. Yeah, there's also a solar rooftop sitting on top, which can also nowadays go on the facade. So I think a quick occupant survey, because in the end we design our buildings for occupants. So sustainability sort of needs to also be tested, in the actual operations rather than only design. So quick surveys were conducted. These are again some visuals. That's the jali on the south that you see, with operable windows on the lower side to allow, a nice inflow of air, then getting exhausted through the atrium and increasing the effectiveness of the direct, indirect, direct evaporative cooling system. Yes. So that brings me to the end of case study, and very quickly I will, I think, move ahead, with some food for thought that I want to leave you with. The current trends in residential, where we are going extremely high rise, where our external walls are concrete and we have a lot of clear glass, not even a high performance glass. It's a very lethal combination, because this is really trapping the heat in our buildings, and it's not letting it, it's not letting the thermal mass of the buildings cool off even when it's the evening, even at night. So conventionally, if a building sort of in peak summer cools off at maybe 4 or 5 o'clock in the evening, this combination would sort of, continue to be really warm and on the hotter side right up till the night, late night. So this is something that as architects or as engineers, we really need to address in the coming times, which directly affects our thermal comfort and thereby affects our energy consumptions. In innovations, of course, there are a lot of solar BIPVs that have come up onto the facade. So glass integrated with generating panels is something that you can definitely explore for a lot of elements, not just the facade, but even glass railings. So that is another area of a new area which we need to also popularize, especially with we going high rise and the terraces not being sufficient for having enough renewable energy. Solar facades is definitely something that we have started looking at and we need to look at. Now, touching a little bit upon low carbon construction and materials, you will see that embodied carbon is also something that needs to be looked at, and not just the operational carbon. And life cycle assessments can be used as a tool for decision making. Now, there are two types of materials that sit within a building, something which affects the operational costs and something which does not affect the operational cost. So when you look at glass as a material, it definitely has an impact on the operational costs and the operational energy consumption of the project. So if you look at the carbon footprint of a single glass, it is 13 kg per CO2 per square meter. But if you look at a DGU, it is of course multiple times that. So it is around 52 or 53 kg per kg of CO2 per square meter. So would you still then say that, okay, then let me do a single glass because I want to reduce the embodied carbon? The answer is no, because the DGU will end up giving you way more savings in the operational carbon than an SGU. And hence, this decision has to be jointly taken by looking at the embodied carbon as well as the overall life cycle of the building in its operational stage, where the DGU will land up actually reducing the carbon, and this will be a good investment that is being made into the facade. Yeah, so carbon emissions are definitely aluminum and glass. They go hand in hand, when you look at carbon emissions. So we do a lot of life cycle assessment works where after steel and concrete, after concrete and steel, then, the most highest embodied elements are, glass and aluminum that we need to sort of look at. So this is a very quick glimpse onto how the LCA analysis sort of looks. So thank you. I hope that my presentation, took you through sort of a journey of how glass can be explored in sustainably designed projects. And I hope that, these new ideas of enabling mixed mode ventilation, of enabling operability of facades, and working closely with HVAC consultants to to deliver efficient buildings with glass as one of the most primary materials in this entire picture I hope that I could, spark some ideas, and yeah, that's all from my side. Thank you.
Thank you, 𝐊𝐚𝐲𝐿, for such a comprehensive and enlightening presentation. You shed light on so many critical aspects, ma'am, like of the sustainable facade design, from decarbonization and energy efficiency to innovative strategies like you showed us in mixed mode ventilation and using of passive design principles. I'm sure everyone in the audience gained valuable insights into how facades can drive sustainability with glass at the forefront of these solutions. Now, before we wrap up this session, I'd like to take this opportunity to ask you a few generic and basic questions that our audience might find interesting.
Sure.
So, with India's diverse climate zones, what are some unique challenges architects face while designing facades for extreme climates, and how does glass help overcome them?
Right. So I think one of the main challenges that architects face is, between the expectation from the client with a global image, wherein, like I also said, that you want all facades to look similar, maybe, or so there are these design challenges where there is a certain level of resistance to give importance to the performance side of glass. And it is often only the aesthetic side of glass which is given importance. However, like I began my presentation with, that if there is glare, you are going to be blinds down, and nobody is going to actually be able to use the beauty of that glass and the transparency of the glass. So I think breaking that barrier somewhere is also what architects struggle with, to balance sort of between the two, and convince the clients that okay, this has an impact on the operational energy consumption and on your thermal comfort. And I feel that with the kind of, and how glass can actually solve it also, is that the kind of range of glasses that is available right now. So right from photometric glasses to and I think glass is also sort of sought for because it is easy to clean and maintain. It is a single system and does not have like I don't have to paint my building again and again, or refurbish my renders again and again. So from that perspective also, I think people do love glass. I forgot to mention while I was talking about embodied carbon, but Saint-Gobain has also launched a low carbon glass. So anybody who's actually seeking for a low carbon product, can also have those options available now in the market. So I feel if judiciously used, if consciously used with the correct technical backup, and also being cost effective, because in the end you cannot use like the best of glass and then it's like 10 times more expensive than what you would have done. You cannot do that in the real world. So I think it's a balancing act, I think, and glass does offer you those opportunities of connecting with the outdoors, allowing that daylight, which makes you, feel human, feel productive, feel connected to the nature. At the same time, being able to feel the air that, properly operable glass panel allows you. So I think somewhere there is a balance in what is the context of the project, what the client wants, and and I think also the trend that we need to set is the integration with the air conditioning system of the facades somehow, because we are still working in silos when we look at facades and then air conditioning. So I think, yeah, those are the hurdles, and I mean, a lot to be done there actually.
Right, absolutely. So, next question, we've already touched upon this topic of life cycle assessment. So, it's increasingly being recognized as one of the most powerful decision-making tools to reduce the environmental impact of materials and the products. For our audience, could you briefly explain what LAC entails, or like additionally, are there any specific tools or softwares that you would recommend for conducting these life cycle assessments on facade materials, maybe particularly glass?
Yes. So life cycle assessments, as the name suggests, sort of calculates the entire impact of any product or material right from its birth. So it is called as a sort of a cradle to gate, a cradle to grave, or a cradle to cradle sort of an approach, where, right from the extraction of raw materials to the processing of that material, and there's a lot of energy and resources that go into the manufacturing of a certain material. So whenever we speak on sites, we often tell them that even if you save 1 kg of something, it is of value. because there is that entire, upstream chain that has, manufactured that product, and it is of real value. I mean, just like we say, in our electricity transmission, that, 1 unit that you save at a user and lands up saving 4 units at the generation point. So similarly, the same goes with materials, wherein the LCA looks at, all these impacts right up to its end of life, and what happens after its life ends, after its use ends. How does it go back into the cycle? Does it get recycled? Does it go into the landfill, or does it go to some other industry? So all of these impacts are captured in a LCA, and it's not just the carbon or the GHG emissions, but it is also impact on other environmental systems like water, fresh water, toxicity in the environment, and how it affects other sort of natural elements as well, and not just the GHG. So that is what a LCA looks at. The LCA looks at the overall environmental impact of a particular material. And the simple rules we already sort of knew. One was, upcycling any material, using recycled products available. Like we often very loosely say that, yeah, aluminum is recyclable. But are you using aluminum that is recycled? Or are you banking on something that somebody is really not doing? So these small things are cues which you need to ask. Or when you're using concrete, are you using some sort of a pozzolanic material in high percentages? It could be GGBS, it could be fly ash. So having recycled content, saving carbon emissions during the transportation by sourcing the products in the right way closer to your project. All these were small tips that we all knew since a long time, which in the end reduce the carbon footprint. However, now you have tools to specifically calculate that, okay, if you go from recycled content of 18% to recycled content of 25%, this is the impact in the entire life cycle that you would get, right? So it has become more specific in terms of, you are able to calculate it now. There are a lot of Indian databases also that are available, not just global databases specific to vendors, manufacturers, because the entire supply chain in the construction industry is now measuring their carbon. So, there is, it's striding in the right direction, and we can actually calculate the exact carbon footprint of a project, see if we replace this material, that material, what happens, is it cost effective, and so on and so forth. So there are many tools, some of them are, also freely available. But tools like One-Click LCA, SEMA Pro are paid softwares which can be used for doing this LCA analysis. But no worries, even if you're students and you don't want to, you cannot invest in a software right now, using these simple techniques of going for recycled content, asking for recycled content, will land you saving some amount of carbon. Because the trick here is every material in the industry claims to be green, right? You go to any expo, you will see everybody is green. So they are claiming one or the other attribute. So it is very tricky, and you really need to de-jargonize or everything, and then be able to see the true meaning of eco-friendly materials down there. So the LCA will help you to do that. When you compare LCAs, you can cut the jargon and you can say, okay, no, the environmental impact here is lower. So it's sort of a good way of communicating the actual impact of a material.
Absolutely. This brings us to the last question, ma'am. So you worked on numerous green building projects and sustainability initiatives. If you had to give one piece of advice to the young professionals entering the specific field of sustainability and architecture, especially in the context of facade design, what would it be?
I think the only message I would have is challenge what you conventionally see, and try to, because I think today it's easier to design a facade which is completely glazed versus, actually finding enough of opaque materials which are durable. Like if I tell you, to design a facade with less glass, it is a challenge. And it's more easy to simply do a completely glazed facade. So I think, yeah, it is challenging the conventional trends, and looking at and stop working in silos. I mean, look at the fellow consultants and sort of in an integrated approach. I think that in itself is a game changing sort of a thing to do on any project. If you are sitting early with the cooling consultant, if the architect and the cooling consultant along with their clients, and maybe the facilities person sits together at the beginning, I think whatever comes out of it, with whatever financial budgetary provisions you have, will definitely be way more meaningful than working in silos. So I think don't work in silos, challenge what is conventional, explore newer, technology and material which will sort of help us decarbonize, reduce our consumptions of any resources, be it water, energy, materials, because everything is of value, because it is sourced ultimately from nature. So I think that's the core of it all. So anything you save is a saving. It's even a small quantum of saving is of high value, is what I would like to say. And
Very
conclude maybe.
Thank you so much for answering all those
Thank
questions
you.
thoughtfully and for sharing your deep expertise in this critical topic that we discussed today. And your insights have provided our audience with actionable knowledge and renewed appreciation for the possibilities of glass in modern architecture. And on behalf of Glass Academy and Ethos Empowers, I extend heartfelt gratitude for your time, for sharing us this invaluable knowledge with us. And to our audience, we thank you for joining, and please stay tuned for exciting webinars where we explore innovative ideas like these and technologies that shape our built environment. Thank you so much, ma'am.